Hello and welcome back to Math 1500 Applied Business Mathematics at Connecticut State Community College. This is section 8.4, Probability and Counting Techniques. For those of you who are taking this course with me, this is it. This is the last section of the course, so I appreciate you sticking it out. And we have one last video, and essentially it'll go fairly quickly. Three examples that I want to work with. We're going to review probability. Okay. Remember that an experiment in which all outcomes are equally likely, the probability, so talking about the probability of an event, is given by, the probability of E is the number of favorable outcomes divided by the total number of outcomes. So you'll notice in example 1, we've got a bag containing 4 red marbles, 2 green ones. So let's write this down as we go. In the bag, there are 4 red marbles and there are 2 green marbles. Upon seeing the bag, Susan sticks her hand in the bag and she just randomly grabs 3 of them. Find the probability that she will get both green marbles. Well, the first thing I want to do is I want to notice that there are 6 marbles total. So if there's 6 marbles and she chooses 3 of them, we've done this before, that's 6 choose 3, and I'm going to use my calculator for this. Math, probability, number 3, math, probability, number 3, 6 choose 3 would be 20. So there are 20 different combinations of 3 marbles, and we don't really care the order that she picks the marbles. The question is, what's probably that she gets both green marbles? In the previous video, I did a tree diagram. We could list all the possible outcomes and count them. We don't really need to do that. There are 20 possible outcomes. So in our probability here, right, the probability of E, the total number of outcomes, that's our denominator here. So the probability of E, we have a denominator of 20 total outcomes. Now, there are only 2 green marbles. So she does need to choose both of the 2 green marbles. So that would be choose 2, choose 2. Also, from the other 4 marbles, she needs to choose one of them. Now notice that she grabbed a total of 3 marbles. 2 and 1, that adds up to the 3 that she picked. 2 and 4 here are the 6. Okay? So, I'm going to do these without the calculator. 2 choose 2 is 2 factorial over 2 factorial, 0 factorial, which is 1. And then we have 4 factorial over 4 minus 1 factorial, 1 factorial, which is 4. 1 times 4 is, that's an ugly 4. 1 times 4 is 4, so our numerator is 4. So the probability of this occurring is 1 out of 5, or 0.2. Okay, so total outcomes, favorable outcomes. Similar problem, a little bit different. A bag containing 4 red marbles, 3 green ones. Let me write this down as we go again. 4 red marbles, 3 green marbles, 2 white marbles, and 1 purple marble. Okay, that's a total of 10 marbles. Okay, that's a total of 10 marbles. This time, Susan grabs 5 of the marbles. Find the probability that she has 10 red marbles, 2 red marbles, and 1 of each of the following colors. So she wants to pick 2 red, 1 green, 1 white, 1 purple. First of all, let's get the denominator for the probability of E. That would be the total number of outcomes. 10 marbles, she's going to randomly choose, she's going to grab, she's going to get a combination of 5 of them. I'm going to copy and paste. So of the 10 marbles, she's going to grab 5 of them. So there are 252 different possible combinations. 252. How many of those combinations we'll have 2 red. Okay, let's do 2 red, 1 green, 1 white, and 1 purple marble. Well, the probability of 2 red, or the number of 2 red, from the 4 red marbles, she's going to choose 2 of them. From the 3 green marbles, she's going to choose 1 of them. From the 2 white marbles, she's going to choose... From the 2 white marbles, she's going to choose 1 of them. And from the 1 purple marble, she's going to choose 1 of them. So, let me keep going down. 4 choose 2. 4 choose 2 is 6. 3 choose 1 is just 3. So 3 choose 1 is 3 factorial over 2 factorial, 1 factorial. So that's just going to be 3. So 3 choose 1 is 3. 2 choose 1 is 2. 1 choose 1 is 1. And when I multiply 6 times 3 times 2 times 1, I have 36. So the probability is 36 over 252. 36 divided by 252. Now that looks like I want to write 0.1429, something that's always not a bad idea. Press math. Notice number 1 says change to a fraction, and that's actually 1 over 7. So that would reduce to 1 over 7. And so there's my probability there. I said 3 examples. It actually looks like there might be a 4th. The Saudi State Lottery requires you to select 5 different numbers, 0 through 49. Now be careful, 0 through 49 is not 49 numbers. That would be 50 total numbers. You're a big winner if the 5 numbers you select agree with those in the drawing. You're a small fry winner if 4 of your 5 numbers agree with those in the drawing. Okay? So, what's the probability of being a big winner? First of all, how many total outcomes are there? From the 50 numbers, you're going to randomly choose 5. Math, probability, number 3. 50 numbers, you're going to choose 5. I bet it's going to be a big number. So that would be 2,118,760 different possible 5-number combinations. The probability of being a big winner is there's only one that's a winner. So the probability that you're a big winner is 1, because of the 5 numbers, you have to choose all 5 of them, and that would be 1. So 1 over 2,118,760, that would be the probability that you're a big winner. The probability of being a small fry winner, you're going to have the same denominator of 2,118,760 total possible outcomes. In this case, though, our numerator is a little bit different. Of the 5 winning numbers, you choose 4 of them if you're a small fry winner. And of the 45 non-correct numbers, you chose 1 of them. So of the 5 numbers, you chose 4 correct numbers, 1 wrong number. Again, notice, and I showed this to you in an earlier problem, that 4 plus 1 is 5, the total number of correct numbers. And then 5 plus 45 is 50, the total number of numbers selected. So if I now simply do 5 choose 4, which is 5, times 45 choose 1, which is 45. You can do that on the calculator to check me out. 5 times, nope, not divided by, 5 times 45 should be 225. So 225 over 2,118,760 is the probability of being a small fry winner. If I change that to a decimal, whoops, forgot the 8 there, 2,118,760. That's a very small number. If I try to change it back to a fraction, it might not even change it back. Okay, so that would be approximately 0.000162%. So that's about a 0.02% chance of even being a small fry winner. Now, what's the probability of being either a big winner or a small fry winner? Well, that'd be 1 over the 2,118,760. That's the probability of being a big winner. The probability of being a small fry winner is 225 over 2,118,760. So the probability of being either a big or small fry winner would be 225 plus 1, which is 226, over 2,118,760. Okay, so here's the probability of being a big winner, small fry winner, big or small fry winner. Okay. Last example that'll go fairly quickly. Monkey at a typewriter. Okay, suppose that a monkey is seated at a computer keyboard and randomly strikes the 26 letter keys and the space bar. Find the probability that its first 39 characters will be to be or not to be. That is the question. Okay, we want to leave this as a fraction or a formula. The WebAssign assignments will ask for a formula. Okay, so, I mean, if you think about it, let's do this a little bit differently. What's the probability that you flip a coin and it comes up heads? That would be 1 out of 2. What's the probability that you flip a coin 10 times and it comes up heads all 10 times? You get the correct outcome all 10 times. That'd be 1 out of 2 times 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 1 out of 2, and you would do 1 over 2 to the 10th, which is 1 to the 10th, over 2 to the 10th, or 1 over 2 to the 10th. And we'll just leave it as the decimal. Okay? So this is very similar to that. It just seems a lot bigger. Okay? So what's the probability that the first key that the monkey hits is the T? That'd be 1 out of 26 because there are 26 letter keys at the space bar. That would actually be 1 over 27. 27 letters in the space bar. That's for the first T. Then the O, I'd multiply by 1 over 27 again. Space times 1 over 27. So really, I need to hit the right letter. Probability is 1 over 27, 39 times in a row. That would be 1 to the 39th over 27 to the 39th. 1 to the 39th is 1. No matter how many times you multiply 1 by itself, you will get 1 over 27 to the 39th. Simple as that. All right, that does it for us. That's the end of the course. If you found these videos helpful, I would really appreciate it if you would like or subscribe, and I wish you all the best.